You ever wonder why the brilliant engineer next to you has seemingly perfect diffs while yours gets 1,000 comments telling you how much you suck? It's probably because he actually thinks and plans about his code before writing it. You want to be like him, so you ask him, hey, how do you do it? He answers, I just plan. Naturally, you decide to ignore his advice and then come ask me for help. So today, we're going to actually talk about successfully submitting engineering projects. It's something you're going to do all the time in your career. Lots of companies really like to give their employees this idea or this talk of submitting projects consistently and efficiently, but no one really has a definitive guide for it. There are many books on this, and each one of these sections deserves its own thesis. But I'm going to give you my own broad level framework for delivering projects, and this works for any project, whether it's a small bug fix or a large-scale migration. Okay, first, we start with project planning. No, seriously, this is actually pretty important. Planning allows you to buy yourself time without committing yourself to a project. It gives you time to think about what you actually need to do with proper planning, and you can actually take on larger projects with other people. And this applies to any level, bug fixes or company-wide language migrations. The questions that you need to ask yourself at this stage are, what do we know? Have other people tried to make this or fix this? What insights can other people give us into solving this? And is there any documentations? Now, this isn't the only questions that you need to ask. These are just a few samples, because the higher up you go in your career, the more time is spent on planning because the project becomes so much bigger. You cover every single possible area that you can, diving into the history of the project and then setting the roadmap and solution for the task. One great tip I have is to take notes on any and all discussions that you have and record them if you can. Zoom, fortunately, has an Otter AI integration, and so you can actually do both with just one click of a button. And if you don't have that, I recommend just taking notes on a Google Doc during that conversation. Coworkers appreciate you taking a little bit of extra time to make sure that they don't have to repeat themselves. Once you're confident in your idea and plan, it's time for the next step, testing your idea. So the first step here is to test the idea out or to prototype it. We have a plan in place and we want to see if it works. And there are many different ways of solving a problem. This is where we get to try out all our fancy ideas and prove that our plan will work. Writing clean code that actually solves the problem, building off some other people's projects, writing some hacky script, copying some code online. These are all a bunch of different ways that you can actually test your idea, because nothing really works in reality as we think it might. We might think that a bug can be solved in one particular way, or it's just one and done. But we are often wrong about that, which necessitates actually trying it out before fully committing to it. This is why it's important to test out the prototype, and this is why we make the distinction between the prototype and a finished product. For many of you junior engineers, this is just a novel concept, and it's not surprising. After all, for most of your careers, the engineering challenges have mostly revolved around fixing bugs and shipping products very quickly without a second thought, or without maintaining it in the future, almost following the old Facebook ethos of moving fast and breaking things. So this idea might be relatively new to you, except for the fact that no one told Facebook that breaking things might cost millions of dollars in productivity. The bonus of actually trying to prototype here is that you also get to see how everything works in conjunction with your project before it finishes. You get a better insight and understanding of what it is you're working with, and it will mean that you will have a more meaningful discussion going forward. Any significant issues you run into should be documented, especially if you have a fix for it. Chances are someone else down the road will have a similar issue as well and will encounter it again. Documentation and extra information is always good, and future developers will thank you for it. Next is formally submitting your proposal. Mark the milestone and set the expectations. I recommend you start this step only when you are 85% confident about the steps and tasks. I say this because there are always a couple of things that you are going to miss, but it's up to you to set the vision for these projects, even if it's just a very small bug. After all, how do you think this bug should be solved? And it's your job to actually fight for it. In the beginning of your career, this is actually pretty simple. You're going to be fixing bugs, and usually the problems and expected behavior are pretty much written out for you. So there really isn't much scoping as to what the end result should look like. But as you get promoted, these changes becomes a little more nebulous and a little bit less clear. It is up to you to say what is correct and done because projects get more complicated and the requirements get more vague. From simply writing a small feature to writing infrastructure-related projects where the end project is poorly defined. Setting the vision for what the solution should be and why will help people understand what exactly you are trying to build, and a solid step-by-step plan is the best way to paint the picture. Not only that, it also helps in getting other people on board and delegating them tasks. You can say person A does one step, person B does the next step, and person C does the third step. It's very easy to get buy-in in this way. For instance, one major problem is when people say that they are quote-unquote done with a project. Well, what exactly does that mean? Does it mean it's bug-free and we can ship it? Does it mean that it's in maintenance mode and that we can just deal with bugs as they come up, if they come up? If you're writing a product or general migration, what constitutes correctness? What will you test for it? How will the code work? And what features will it have? This is where planning and setting expectations are going to come in and be very important. Setting a well-defined goalpost and the approximate steps in between here and there in order to accomplish it is going to be a very meaningful way of actually trying to get other people to understand what it is you're talking about. This step also includes a formal ERD reviews and negotiations on timelines with leadership and getting buy-in from your coworkers. Hopefully, you've had an informal chat in step 1 with all these same coworkers so that this doesn't actually come out of nowhere. Now, a few tips for this step is to not just consider what the end product should look like. Consider one more step beyond that. How can you scale your product and let other people use it? When fixing bugs or delivering products, we often just call it done and move on and assume that it will be dealt with at a later date. As long as the metrics are to spec and the project managers are happy, then whatever, right? But many times, a lot of other people may run into similar difficulties or problems that you faced in this project. They may even want to reuse portions of your code and even the feature itself. While it makes sense to make these things reusable, there is a very delicate balance. If you make things too easily changeable, then people don't understand why the code was written to begin with, or it will be too complex to use. But if the code is not easily changeable, then nobody will use it because it won't even fit their needs, and they can't change it to fit their needs. This is where objective thinking comes in. Thinking about what purpose and why you may want things to be reused, and what problem your code is ultimately trying to solve. Because at the end of the day, code is here to help solve that problem. And every variable that any person can change should correspond to a reasonable variation of the original problem that you're trying to solve. Is your product going to be used in other marketing campaigns? Is your tool going to be used for specific circumstances? What do you want to let the end user change? And what do you want to keep absolutely unchangeable? The reason you would want to expand your product or tool is because it allows you to multiply your impact. If other people can save time by reusing your code, then it's a win for you and a win for them. Now the hard part, how to handle submitting diffs, or in this case, little code snippets that are your changes. This is where we get to step 3. Do the task, and for every diff, make sure it's small and manageable. Yes, no matter how many times we hear it, a lot of the advice comes down to the exact same idea, splitting up your diffs, testing well, and so on. But we still run into the exact same issues very often. So I'm only going to briefly address the advice out there. When you submit your changes, they will appear in a merge request or a diff. It will ask you to submit your comments, your testing plans, and whatever reviewers you want to have a second look at your code with. The diff is just all the changes to all the files, and very rarely should you have a very large amount of changes all at once. If you are planning poorly, you should be able to divide your plan into discrete, self-sufficient steps that are fully functional. Each step should represent one singular simple idea, and each follow-up diff should build on top of that previous idea. Now, what should your summary look like? Usually linking a ticket or adding a link to the original report will be good enough, but some changes aren't very obvious. It's simply easier to add a small write-up on top of your diff in order to justify its existence. And it will mean saved time for you because you won't have to wait an extra day or two when someone inevitably asks you why the changes are needed. After all, if they're reviewing the diff, they're going to wonder why it's even needed in the first place, and they're not going to necessarily open the link. It's better to have these changes right in front of them and an explanation right there so that they don't have to ask these questions. Ideally, the changes in code should be self-explanatory, but you should take the initiative to comment on the areas you feel are going to be easily misunderstood or vague or raise issues from another person. The second tip I have is to screenshot your tests. A common way to get blown up and blamed for issues is that after submitting a diff, someone else makes a change to something that you're dependent on. This results in your code reading a different output and then your section of code failing. After that, your manager will ask you if you've tested the code, and even though you have, the fact of the matter is that the code still failed. In other words, the manager still doesn't trust you because you failed to actually anticipate one test case. Having screenshots of what you tested is a good way to save your credibility. After all, it shows that we really did test it in a bunch of different and reasonable use cases. Plus, you should be running the tests anyway, so what's an extra 2 seconds to screenshot and upload the tests? This is especially helpful on notoriously flaky mobile app development, where video recording of end-to-end testing can show people that you really did try to simulate a reasonable use case and every other test case. Another tip for this part is to write the problem areas in the test plan. Much in the same line as above, you should write a small summary of what you want to test and why, what the changes are going to affect, and other issues that you are anticipating, and why you think that your plan is enough coverage. The most efficient way is through a matrix, a permutation of parameters and environment contexts, multiple dimension and states. This is not unlike testing actual code, except you're testing the tool and code against multiple non-code scenarios. An example is in changing the CI/CD pipeline. Does your changes work on Mac, Linux, Windows, and other environments? Does your change affect all the downstream dependencies and other pipelines? Can you show that the pipeline works even in spite of all your changes? In an especially unknown and poorly documented area that you are not 100% confident in, don't be afraid to ask someone to check your blind spots. This helps limit your liability because now you have someone else to vouch for your efforts and care. Now, this all sounds well and good. Just keep churning out diffs and tickets, right? But we run into the issue of running over the time budget. What if we have too many unforeseen issues? What if we turn over a stone and more tickets and tasks need to be handled? Now, one final common problem people have is when a task or project takes much longer than expected or cannot necessarily be fixed. This is more common in bigger projects that span a larger area that is less well understood or anticipated, but can happen for major bugs as well. Maybe a bug is better off left alone than trying to fix it and risk breaking a lot of downstream dependencies. So, if a task or a project is taking too long or is not worth it, you should first document it to close it out. You should be able to document what the inefficiency is, if applicable, and ask if anyone else has handled this issue. Chances are other people are running into the issue as well and can give you insight into this. And by inefficiency, I mean anything that is preventing you from working in an optimal manner. This can be confusing tooling, opaque logs, a super tedious process to dive into the code, or even the issue itself. What steps have you taken? What is blocking you? What is taking you the longest? Why is this taking too long? And why is the further pursuit of this not worth the time? Make sure you've at least acknowledged the slowness and have asked for help. Now, one trick I've learned is that a good way to tell is if there is an inefficiency is if the developer's flow gets interrupted. And by flow, I mean being akin to the zone or plugged in. As developers, we like it when we can just code and do nothing but code. If we have to interrupt this by debugging or some external process that's not related to us, or maybe just going down some rabbit hole or engineering wiki in order to try and solve it, this breaks our rhythm, and it's a great sign that something here can actually be improved. That is an inefficiency that is hampering our productivity. That inefficiency in and of itself can even be a project. So document it, not just for the sake of documentation, but also so you remember what problems you ran into and potentially what problem areas and impact you can have in the future. So I know that this was long, but I'll walk through a few examples in later videos about how this can apply to not just big projects, but also small bug fixes as well. So that'll do for me. Let me know what you think in the comments down below. Also, feel free to follow me on my socials where you can vote for what topic I cover next. And if you want to try and secure the next job offer, you can book me for interview coaching at echantech.com. If you like this video, please like and subscribe, and I'll see you all in the next one.